here is our lecture on the first of the conic sections. It's on ellipses. And I want to draw your attention. I'm in our textbook right now. And in this section on ellipses, they have this big drawn out table with all of these bullets 1, 2, 3, 4, 5, 6 things in there. And what I want to show you is out of all of this, I'm going to try and convince you that most of this you can easily obtain. The only real thing that you need is to know that equation right there. So let me show you what I mean by that. If you look, we have x squared over a squared plus y squared over b squared is 1. So I've brought that over here. Now, that has some sort of a graph to it. There are x's and y's, and a and b would be known in this case. But if we were going to do this and just try and get a feel for the graph as best we can, we might do something like this. I might first do the y-intercept. That's when x is 0. So if x was 0, then we would get 0 squared over a number. And 0 divided by a number is 0, so this would go away. And we would wind up with y squared over b squared is 1. So I get y squared over b squared is 1. And if I multiply both sides by b squared, those cancel. I get y squared is b squared. Square rooting both sides, absolute value of y is b, so y is plus or minus b. Now notice x was 0, so I got 0b and 0 negative b right there. Similarly, if I want the x-intercept, that's when y is 0. If y is 0, this term's going to 0 out for the same reasons, and I'm going to get x squared over a squared equals 1. Multiplying, I'll get x squared is a squared, and square rooting, I'll get plus or minus a. Now, y was 0, so I'm going to have a comma 0 and negative a comma 0. And if I brought a graph in, then, if I knew what a actually was, then I see basically, and this is how I think about it. Also, I'm going to try and teach you a way to think about it right now. In this case, notice whatever's under the x, that piece, if you square root it, since it's attached to that x, it tells you how far to go left and right. And so if I went over here to negative a, and it looks like it's 3, so then let's come over here to a, then those are these 2 points right here. Now, if I want to graph these, let's say b is bigger than a or whatever this time. So let's go up here, and there's 0 plus b, and that's 1, 2, 3, 4, 5, 6, 7. So then this would be the negative b down here. And if I put those points in and connected them up, I would wind up with an ellipse that looked like that. The thing that I really want to tell you in this is the following. That notice the x is the left and right variable, and all you have to do is look right below the x, take that number and square root it, because the square root of a squared is a, and then because x does the left-right, you just look at that and say, well, the square root of that, we're going to go left a, and we're going to go right a, and put a dot. Now, the y is our up-down variable, and so you look under the y and square root that, and you get b, and since y is up-down, you're going to go up b and down b, and put your points in there. So it really is just left and right a, up and down b, and then you just graph it in, and there you have it. So let me show you this then. I'm going to tell you a few things in here. So notice how this axis is definitely longer than this one. So the horizontal axis is longer than the shorter axis. What that it means that this longer axis is called the major axis, and that means that this one, if it's not major, it must be minor. So that's the minor axis. But look, by knowing that you go left and right A and up and down B, if you went up a B and down a B, then how long is that whole red line right there? Well, it's 2B long. And how far is this? If this is A and this is A, then the minor axis should have a length of 2A. So if we go in here, we're in this case here, and I'll tell you something in a second. But see the length of the major axis and the length of the minor axis right there. So in that case, that's what you get when you actually graph it. You can see which one is the major or the minor. Now I want to go back to the book and show you something that I really don't agree with this, but I understand why they do it. But from a student's perspective, it just makes it look like there's a lot more to know than what you really need to know. So let me explain this and break this whole page down for you as simple as I possibly can. So notice this equation and this equation are exactly the same, except in this one, the A is under the X, and in this one, B is under the X. In this, B is under the Y, and in this one, A is under the Y. And so, because that's the case, there's not really two different equations. And so I don't worry about those in that case. What I want to show you now is this. And let me bring up just a blank page. I'm going to now just write a few of these down. Let's take x squared over 9 plus y squared over 25 equals 1. And let's do this. I'm going to show you through this. So we're going to take x squared divided by 9, and then plus y squared divided by 25 equals 1. And when I click over here, you can see what's under the y is 25. The square root of that is 5. And we went up and down 5. When you look at the x, what's under the x is 9. The square root of that's 3. And so I should go left and right 3. And there that is, again, right there. Let's change this now and make it like 16. Now notice that's getting more and more circular. If I changed it to a 1, you see it's very oblong. And so what I want to tell you is the larger the number under the variable and the more there is in difference between the two, the more quote unquote stretched it will be. And so back to the book for a second, here's what I want to illustrate to you. The only difference in these two formulas is that in one they say A is bigger than B, and so then the larger number is in front of the X. This one, A is greater than B, but now the greater number is under the Y. And notice in this picture, it looks like it's what I call stretched more in the X direction. This one is, for this graph, when the larger number is under the X. When the larger number is under the Y, it's stretched more vertically up and down in the Y direction. Let me show you that with a few graphs right now. So I just showed you there if there is a 1, it would change. And if we made it into a 16, it got more close to circular. And as a matter of fact, if I change it to a 25, it's a perfect circle. But if I take this and make it a 49, and come over here and change this to like 4, now notice the larger numbers under the X, and the square root of that's 7, so we should go left 7 and right 7. What's under the Y squared is a 4, the square root of that's 2, so we should go up 2 and down 2, and there you can see all of those points. But my point to you is, If the larger number's under the x, it's just stretched more in the x direction. And if the larger number's under the y, so if I put a 4 here and a 49 over there, now the bigger number is under the y, and so it should be stretched more in the y direction. And that's evident by it being stretched 7 up and down, but only 2 left and right. It turns out if these are the same, and you stretched it 7 left and right and 7 up and down, well, that would be like a perfect circle. And so in that case, you would just have a perfect circle. But if those numbers are different, then you get an ellipse. And the key takeaway is whichever one has the larger number, that is the direction that it gets pulled in. So let's go back to this and say, so here we go. It's x squared over, I just call it x squared over a squared plus y squared over b squared equals 1. And I say this, if a is bigger than b, so that means the larger number is in under the x, it's going to open this way. If b is greater than a, it's going to open up and down that way. That's all that you really need to know. And then once you have that down, then it's real easy to see how long should the major axis be. So let's do this problem here, and we'll take a look at it, and we'll get all of the information we need. So doing this problem, underneath the x, square root of that's a 3, so we're going to go 1, 2, 3, and 1, 2, 3. And under the y, square root's a 5, so we go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, right there. And I'm now going to sketch in that oval right there. I can see that the larger number was in front of under the y, and so it's stretched more in the y direction. That means that's the major axis. So I would say that the major axis length is, we went 5 and 5, so that should be 10. And the minor axis length should be, we went left and right 3, so that should be 6. And if we come over here, in that case, let me make sure which one we're in. So the bigger one's under the y. So we're in this case right here now. And if you look, the length of the major is 2a. Well, in there, a squared was 25, so 2 times 5 is 10, and, oh yeah, that's what we said right there. In this, it says the length of the minor axis is 2b, and b is the square root of what's under x. For us, it was 3, so 2 times 3 should be 6, and that is exactly what we got right here. And then, it said that the coordinates for the vertices are 0, plus, and minus a, so 0, plus, and minus 5. And so we went up 5 and put a dot, and down 5 and put a dot. We said that the co-vertices, so the vertices lay on the major axis, the co-vertices lay on the minor axis. And so the co-vertices should be plus and minus 3, comma 0. And so, oh yeah, it said plus or minus b, comma 0. And then here's the cool thing, and I could try and find a video or an animation of this, but the real neat thing is the way that you draw an ellipse is you have these two foci, they're called, and if you put a string and let it hang limp in between them, and then you pull it tight, and you put a pen right there, and you roll it around, from here, you'll get every point has a distance from that foci to that foci, and then another one is from there to there. So you have from there to there, you have from there to there, and you have from there to there. And it turns out that that length is constant no matter what. And so since that's the case, that's where this winds up coming from in there. But look, we know A and we know B. And since we know both of those, then I can figure out what the foci are. So for me, in this case, we have, okay, c squared should be a squared, which is 25, minus b squared, which is 9. So c squared is 16. So c is 4. So, and they always, the foci live on the major axis. And so in this case, it should be 0 plus or minus 4. And so we should put one right there and right there. And that's where the foci would actually exist. Okay, let's go to some problems, and I'll show you some insight on how to think about them. So in the first set of problems in here, 6 to 10, it says determine whether it is an ellipse. And so the only thing that you need to know about an ellipse is an ellipse needed both of the values of x and y squared. And so here the x is squared, the y isn't, so that one is not an ellipse. Here they're both squared, and so all I have to do is make it into 1, but the answer would be yes, that is an ellipse. And then it says if it's yes, then put it in standard form. So if I took 4x squared plus 9y squared equals 36, the important thing for you to know is it has to be a 1 on that side. And so you must make it a 1. Well, it's a 36 right now, so I'm going to divide everything by 36. And 4 goes into 36 9 times, so I'd get x squared over 9. 9 goes into 36 4 times, y squared over 4. And now it equals 1. And so that's standard form, and the answer to that is yes. Here there's a minus in between, so the answer to 8's no. The answer to 9 is yes, but in 9, you have 4x squared plus 9y squared equals 1. So the cool thing is you have it equals 1 now, but it's just supposed to be x squared over something and y squared over something, and we don't have that right now. So if I put the 4 downstairs, it'd be a negative 1 power. And if I put the 9 downstairs, it'd be the negative 1 power. And I could make this x squared over a fourth plus y squared over 1/9 equals 1. And then, even though we don't like it, it is x squared over, in this case, a squared. Y squared over b squared equals 1. So that is standard form for problem number 9. And number 10 is also an ellipse because you have an x squared and plus a y squared. It would take completing the square to do, and we're going to do them down here when we hit these in just a little bit. So bear with me on that. Okay, let's hit that second section of problems. The second section of problems say, for the following exercises, write the equation of an ellipse in standard form and identify the endpoints of the major and minor axes as well as the foci. So I'm just going to pick a few in here and we'll do them. The first one I'll do is problem 14. So let's see what 14 looks like. If I was going to do 14, right now it says 4x squared plus 16y squared, 16y squared equals 1. That's not in standard form, so I'm going to make it x squared over a fourth plus y squared over 1/16 equals 1. 1/4 is bigger than 1/16. I know that because 1/4 is 0.25. And 1/16 is 0.0625. And so for that, the 1/4 is bigger. So without having done anything right now, I already know because that's bigger and it's under the x, this is going to open left and right, sort of. It's going to be stretched in the x direction and not in the y direction. So it won't be that one. And I can see that just because that number is bigger. Then it says, put it in standard form. So right here, we are now in standard form. So I've done part one of that. All right, so in standard form, identify the endpoints of the major and minor axes. Okay, well, in this case, I know for when y is 0, I'm going to go left and right the square root of 1/4. The square root of 1/4 is a half. So I'm going to go a half and negative 1/2. And then under the y, if we let x be 0, then we go up and down the square root of 1/16, which is 1/4. And so we're going to go up and down a fourth. Then if I bring a graph in on this, we would want to zoom it in a lot more because technically, well, I'm going to do this. I'm going to cheat a little bit. I'm going to make that 1, -1. So I've just scaled it a little bit more. So I'm supposed to go left and right a half. And so there is left and right by a half. And then I go up and down a quarter. And so I go up and down a quarter. And if I then connect those dots, I can see it is stretched, as I said, in the x direction. It crosses at a half and negative a half and a fourth and negative 1/4 on the y. It did say, to identify the foci as well. So in that case, I know this. I know c squared is a squared minus b squared. So c squared should be a squared is a quarter minus a 16th. And so 1/4 is 4/16. Minus 1/16 is 3/16. So c squared is 3/16. And if I square rooted both sides, c would be the square root of 3/4. And so then I know they would be on the x-axis. And so the foci, I would say, are at root 3/4, comma 0, and negative root 3/4, comma 0. I want to show you that problem now in Desmos. So in Desmos, if I just said 4x squared plus 16y squared equals 1, there it is when I zoom in on it. And if I select those endpoints of the vertices and co-vertices, you can see that it can right a half and up and down a quarter. And so that is the same exact graph as we got right here, just zoomed in at a little bit different angle. But hopefully you see I got my my vertices and co-vertices just by going square root that. And this tells me left, right. That tells me up, down. That's bigger, so the left, right's bigger, so that's the major, and so on and so forth. That is pretty much as easy as I can make that. Now let's do a different one. Let's look at problem 16 now. So one thing that I wasn't completely honest about in the beginning, but it's because it hasn't shown up until now, is I've been referring to this page over and over and over again. But if you go ahead a few, there is these formulas. And these formulas are exactly the same. It's just it used to be x squared and y squared here, and now they have x minus h and y minus k. And remember, when we had a x minus h squared plus k, that x minus h shifts the graph to the right or to the left. And so in that case, the vertice is no longer at 0, 0. So let me show you how this works out in this problem. So in problem 16, it says x minus 2 squared over 81 plus y plus 1 squared over 16 equals 1. All right, first thing to note here is, and this is evidenced in the book, notice it's a minus h, and so whatever that is, you put the opposite there. So it's a minus h, but that's a plus h in there. And that's a minus k, and that's a plus k right there. So whatever this is, the vertex is the opposite. So for us, the center is the opposite of the x is 2, and the opposite of what's at the y is minus 1. So this thing's centered at negative 1, or 2 comma negative 1. Now I'm going to pull a graph in right now to then be able to start working on this. So I'm then going to go over 2, 1, 2, and down 1, and I'm going to put a center. Now, all this center does is it acts like the new origin. It acts like now our x and y axis is right here. And so I will still look underneath the x, and the square root of 81 is 9. So from here, now from this spot, I need to go left 1, 2, 3, 4, 5, 6, 7, 8, 9, right there. And so that's right there. Then I need to go to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9 will be like 1 off the page. Now I can figure out what those points are also. The way that I can figure them, and these are going to be the vertices. The vertices, I know that I was already down 1, and I know that I was already over 2. Well, if I was over 2 and I went 9 more, I should be at 11, but still down 1. And if I was at 2 and went left 9, I should be at negative 7 and down 1. Notice, though, if I went 1, 2, 3, 4, 5, 6, 7, down 1, that's that. And if I went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, down 1, that would be right there. All right, look under the y. That's 16. Square rooted is 4. And so from this spot now, I'm going to go 1, 2, 3, 4 up, and 1, 2, 3, 4 down. So 1, 2, 3, 4, and put it up there. 1, 2, 3, 4, put it down there. Once I have that, now I can graph this as best that I can. I can figure out those other vertices. Those are called co-vertices. And I know that I was over 2, but originally I was down 1. But I went up 4, so down 1 and then plus 4. Negative 1 plus 4 should be 3. Negative 1 minus 4 should be minus 5. And so that should be 1, 2, 1, 2, 3. So over 1, 2, 1, 2, 3, yep. And then 1, 2, 1, 2, 3, 4, 5. Yeah, so that's exactly those. Notice I could count them off the graph, but it's easy just to say where was I and what did I do from there. From here, I went left and right 9. So I go plus 9 on that and minus 9 on that in the x. And here I went up and down 4, so I add 4 to that and subtract 4 from that. That's all that's going on in there. Okay, let me pull this up here now. And so I'm going to make it look exactly like they have it. X minus 2, parentheses squared, divided by 81, plus, parentheses y plus 1, parentheses squared, divided by 16. And then equals 1. So there is those spots. And now I'm going to just put in the points that we had. So we said at 2, comma, -1, that would be about the center. And if you look in there, that does look like about where it's centered. We said there would be points at 11, comma, -1, and -7, comma, -1. We said we would be at the point 2, comma, 3 on that minor axis. At 2, comma, -5, right there. So there's all those points, and all of those I grabbed just here from our notes. And they all sit exactly how they should on there. The only thing that I don't have is now I need c squared. And so I know c squared is a squared minus b squared. So c squared, and here's the thing too, I'll tell you guys this. Since a is always the bigger number, you just always take whatever's bigger minus whatever's smaller. And if you mess it up, you're going to get a negative and you'll have to square root a negative, which is going to give you imaginary numbers. And so, for that reason, if you get it backwards, all you have to do is reverse the order. Or just subtract the 2 and ignore the negative, because it should never be negative. This should always be a positive value and always be able to be square rooted. So for us, it's the 81 minus 16. And if I take 81 minus 16, that's 65. And if I square root 65, oh, that I don't think that'll do it. But 4 times 13, no. 65 divided by 4. No. Huh, okay. Well, so this is c squared is 65. If I square root, c should be root 65. And now here's the weird thing. Because the foci are technically on the left and the right, they're on the major axis, and this is definitely the major axis here. What I need to do, and I'll show you. So here's how I would write the foci, and I'll show you how I type it in. I was at 2, but from here, now I have to go left C and right C. So my foci are going to be 2 minus root 65, comma, -1, and 2 plus root 65, comma, -1. I'm going to now add those in to show you. So if I do 2 minus square root 65, get out of there, comma, -1, and 2 plus root 65, get out of there, comma, -1. That should be a -1. You can see the purple and the black are where the foci should be, and that's all the information that you can glean from it. If I needed to, because I see that I went left and right 9, I know the major axis has a length of 18. Sorry, and because I went up and down 4, I know the minor axis has a length of 8. And that's pretty much everything you can get. Notice every single time, though, so far that we've done a few problems, every single one of these, once I know where I'm centered, I look under the x, go left and right, whatever the square root of that is. I look under the y, and I go up and down, whatever the square root of that number is. And so I find my center and go left and right, up and down, draw in my piece, and then the only formula I've needed is that one right there. And even this one isn't hard, because a squared plus b squared equals c squared is the Pythagorean theorem. So just remember, it's the Pythagorean theorem with a minus in it. And there's only one place for an operation sign in the Pythagorean theorem. And if that changes from a plus to a minus, then you'll never forget this formula either. So I remember that it's the Pythagorean theorem for an ellipse with a minus, and that's the only thing I need to know. And then I look under the x for my left right, under my y for the up down, make sure it equals 1 every time, and you should be good, okay? I am going to, so let me tell you what I'm going to do right now. That'll get you up through problem 19. You should, or yeah, up through 18. You should be able to do all of those now and understand. In 19 through 26, these all take completing the square. And I'm going to post a link to a video I made earlier in the term that not everybody watched. And I'm going to have you guys watch that video first, and I'll make one of this tomorrow. Then from there, these we've already done. So it says graph them, noting the center, vertices, and foci. I like just graphing them because then I can pull all of this information once it's graphed. And so we will talk about those. And in 46 and 47, these are some of my favorite ones because they give it to you a situation in words. And then after that, what I want to show you is the very last thing. Look at some of these problems. So these are the ones that we would do normally later on, but let me show you now since we're doing them. Look at problem 52. It says, and these are really fun. It says for the following exercises, given the graph of the ellipse, determine what its equation is. So in 52, I see this. And so here's the deal. I know it's going to be x squared over something plus y squared over something equals 1. And all I'm going to do in this is go, oh, it looks like I went up and down 6. Okay, well, then that would mean I need a 36 there. It looks like I went left and right 4. So that would need a 16 right there. And so now I want to graph that and see if that produces what I thought. So going back, I got x squared 16 and y squared 36. Okay, so x squared over 16 out plus y squared over 36. 36. Whoops. Get down to 36 equals 1. That crosses at 6 and negative 6, at 4 and negative 4. That's exactly what that picture looks like. As a matter of fact, if I pulled this over a little bit, they would almost perfectly lay on top of each other. So you can see what they look like. So all of those problems are kind of done the same way. In this one, you see I went up 7 and down 7. So I had to have x squared and y squared, and it equals 1. If I went up and down 7, I would have seen a 49 there. And if I went left and right 5, I would have seen a 25 there. So there is that piece right there. And then this one, it looks like if I went over 1, up 3, that would be the center. And so in that case, I know then if 1, 3 is the center, it should be x minus 1 squared over something plus y minus 3 squared over something equals 1. So all this is going to do is shift the center from there. This will make it go right 1, and this will make it go up 3, and it'll wind up right there. Now that I'm in there, I can see it looks like I go up and down 1. So underneath the y, this should be a 1. And then in the x, if I was at 1 and went up to 4, that's a 3. Let's see, 1, Yeah, down to -2. That's 1, 2, 3, and that's 1, 2, 3 right there. So if I went left and right 3, I must have seen a 9 in there. And so let's graph that one, and then I'm gonna cut it off. So we have x minus 1 parentheses squared over 9 plus y minus 3 squared over 1. So we have parentheses y minus 3 parentheses squared over 1 equals 1. So there that is right there. If I graphed our 3 comma 1 or 1 comma 3, sorry, 1 comma 3 point right there, then from there, if you went left 3, you should be at -2 comma 3, and then you should be on the other side over here at 4 comma 3, and then up and down 1, 1, 4, and 1, 2 is going up and down 1 from there. In that case, how to do these problems, and these are actually, like I said, I think they're pretty fun. This one is centered at the origin, and this one is switched a little bit. And so just as a recap, I'm going to make another video. Probably my voice does still hurt today, but I'll make one tomorrow, and we'll finish up these types of problems, and we will go through the completing the square. And when we do them up here, even though it only says we want the points of the major and minor axes and the foci, I graph them anyway. And so when you have to do it down here, these will be the same as these up here. So I'll make a video tomorrow doing these and some of these, and then you'll be able to get through all of that. And then we'll go into hyperbola tomorrow too. All right? Take care, you guys. Hang in there, and I'll be talking to you soon. Okay? Bye-bye.